Hey, good morning everyone again. Last time I briefly introduced vectors and scalar, right? So the differences between scalar is what? Scalar is only about quantity, while vector has a quantity and direction. And the vector concept, this lecture today is extremely important because you gotta use this part over and over. And I have seen a lot of students, having trouble with this concept. Okay, so make sure you understand today's lecture clearly. Okay, again, vector has two quantity, right? Two parts, right? Quantity and direction, right? So you already learned one vector. What was it? Displacement. In one-dimensional space, whenever you talk about displacement, you have to describe as a direction either to the right or to the left, right? So displacement is vector. And another vector you learned last time is what? Velocity. So whenever you are asked to find displacement or velocity, you always have to describe its quantity, magnitude, and the direction, right? And then the example of scalar was what? Speed, right? Okay, and the next one is the core part of today's lecture. So the idea is very simple. You will have a right triangle initially, right? So you have a right triangle, and the right triangle, let me use the whiteboard. So let's think about a right triangle. Because this is a triangle, it always with a three lines and three angles, right? So basically, because I call this is a right triangle, you always have a one right angle, 90 degrees. So basically, except this right angle, you will have two additional angles. So I will call this is a theta 1, and I will call this is a theta 2, right? And again, because this is a triangle, you have three lines, right? So I will call this is A, and I'll call this is B, and I call this is C. Especially A is what? Hypotenuse, right? So this is a hypotenuse. So again, three lines, three angles, right? So basically, we are interested in finding the length C and length A of a triangle. Okay. So then now let's think about the very fundamental definition of triggers, right? So first of all, what is the sine theta? Sine theta 1. What is that? C over A. And what is the cosine theta 1 is a B over A, right? So then if you multiply A both sides, you can see C is what? A times a sine theta 1. Here you see B is A times a cosine theta 1, right? So this is a C, here is A sine theta 1, B is A cosine theta 1. So okay, so far so good. This is not complicated, right? The easiest way to remember this formula is what? Whenever you have this type of triangles, right? So you have to see hypotenuse first. So always hypotenuse first. Hypotenuse first, right? And then C, so again, the very first step is you identify hypotenuse. And the second one is you have to choose one angle. So here I said again, because this is a triangle, there are three angles, right? So except 90 degrees, you basically have a theta 1 and theta 2. So you have to choose one angle. So assuming you choose a theta 1 as your angle, so then line C is what? Opposite to theta 1. And then line B is what? Adjacent to theta 1. So if it's adjacent, then you have a cosine. If it's opposite, then you have a sine. Again, hypotenuse first, and then you choose the angle, either theta 1 or theta 2, two angles, one of the two angles except the right angle. And then if the line that you're looking for is the opposite to the angle that you choose, then you're going to use a sine. If the line is adjacent to the angle, you use a cosine. So then now you will have a question like this. Okay, what if I choose theta 2? Then what will happen? Let me see. If you choose theta 2, you see here. Now line C is adjacent to theta 2, right? So in other words, line C is adjacent to theta 2 or opposite to theta 1. So in other words, that means if you choose theta 2, line C is what? Always a hypotenuse first. And then line C is what? Adjacent to theta 2, so it's a cosine. And then line B is again hypotenuse first. And then line B is opposite to theta 2, so it's a sine theta 2. So then now you see very interesting result here and here. So in other words, C is what? A sine theta 1 equals A cosine theta 2. This makes sense, right? Because the length, you never change the length of C, right? The only change we had here is what? We changed our choice of the angle, right? So basically, it doesn't matter which angle you choose, except the right angle. You will have the same answer anyway, right? Why? Because this is because of a very important trig property. Why? What is that? Sine theta is a cosine 90 minus theta. In other words, sine 30 degree is what? Cosine 60. They both are 1/2. So, because this is a right triangle again, and this is a right angle, right? Sum, theta 1 plus theta 2 is always 90 degrees, right? So really it doesn't matter which angle you choose, you will anyway have the same answers. Okay, good. Again, so to sum up, right? So there's three angles, three lines, right? And the one angle is a hypotenuse. The one line is hypotenuse. One angle is 90 degrees. So basically you have two options for the line and two options for the angle, right? So you have to choose one of these angle and then finding the other two lines, right? And then if the line is adjacent, opposite to the angle, right? Adjacent, cosine, opposite, sine, right? So this is a simple, but if you have now let's assume you have a different, shape of a triangle, but the rule is the same. So now another example, let me see. Yep, another example. Let's see here is, let's say, what is that is going on? What is going on? So now you have a right triangle, right? This, right? And then again, this is 90 degrees, and this is your hypotenuse. So we're not interested in general the hypotenuse itself. So basically, you are interested in finding length A and length B. And then again, you have two angle options, right? This is a theta 1. This is a theta 2. Whatever we call it, doesn't matter, right? So now the question is, what is A? There's two ways you can find length A. Again, which one first? hypotenuse always first. And then if you choose theta 2, line A is adjacent to theta 2, right? So it's a cosine. So it's a cosine theta 2. Or you can also use a theta 1 to find the A, right? So the hypotenuse first, and then because this A and theta 1 is opposite to each other, so you have to use a sine theta 1. Right? Can you guys can you pause the video and try to find the B in two different ways? Okay. So B is what? Again, hypotenuse first. So in order to find the B, if you choose the theta 1, this is a adjacent. So it's a adjacent cosine theta 1. Or if you choose the theta 2, line B is opposite to the angle theta 2. So you have a hypotenuse first and then sine theta 2. Right? It's the same, right? So it really doesn't matter which direction of a right triangle you have. So again, we can also have a this right triangle, right? So then this is a right angle. This is a hypotenuse. You're basically interested in A or B. And then pause the video. But before you pause it, let's say this is theta 1. This is a theta 2. Pause the video, find A and B using theta 1 and theta 2. Okay, so then let's find A first, right? And then if you choose the theta 1, A and theta 1 adjacent. Adjacent cosine. So hypotenuse first, adjacent cosine, so it's a cosine theta 1. If you use the theta 2 to find the A, this is the opposite, right? So then you have a hypotenuse and then sine theta 1. If you're looking for B, hypotenuse first, and then theta 1 is now opposite, theta 2 is adjacent, so it's a cosine theta 2, or H times sine theta 1. Okay. Good. I think make sure you really clearly understand this lecture, because this is one of the most confusing part of the early physics 1. Okay. And now this is all we did, right? And then another thing is you can also find the length of h, right? Because this is a Pythagorean theorem, so you have h is a square plus o square root, right? And then sine, cosine, tangent, and then we have a adjacent opposite. This is exactly what we just did. And then in addition to that, we can also have a tangent theta, right? Tangent theta, just to review, go over what you learn in high school, right? Tangent theta is O over A, right? For this triangle. Right? So the real question you have sometimes, okay, I have a displacement, 20 centimeter, and then angle, one of the angle is given. So if this is 30 degrees and the other one automatically 60 degrees, right? But we don't need it, right? But so if you're looking for x, what is that? Hypotenuse first, which is a 20 centimeter. And then this x line is adjacent to this angle 30, so it's a cosine. Then you will see this is a 17 centimeter. But again, you can find this one again using different way. How? This is also 20 hypotenuse times what? Sine this angle, which is a 60. Why? This is a opposite to it. Right? Then you'll see the same answer. And then y, if you're looking for y, again, hypotenuse first, and then this angle, and then this y is opposite to each other. So you have a sine. Another way you can find it here is 20 times cosine 60, right? And then you will see the same answer, right? So far so good, right? So then now let me introduce inverse function, right? I believe you guys know inverse function, right? What is the inverse function? Let me see. Yeah, inverse function is what? So for example, you know, if you have this type of triangle and then let's say this is 30 degrees and then you know sine 30 degrees is a 1/2, right? So that means that this is a 2, this is 1. You know, one of the example, or 4, 2, doesn't matter, right? But the question is, so in general, your angle is given, and then you're looking for the ratio of this between these two lines, then you can find the sine theta, right? So then basically the function you have is, okay, I know sine and I know 30 degrees, and what is this value, right? But the inverse function is what? Okay, I don't know what angle is, so that means, okay, I don't know what is this. But I know the answer, 1/2. So then, how you find the angle here? Then you have to use a inverse function. So the symbol for this one, inverse function is what? Sine inverse 1/2. So if this question is simply what? One angle make a sine value 1/2. So the answer is 30 degrees. Okay, that's the inverse function. And okay, for example, displacement is a vector again, right? So now let's say you have a displacement, boom, right? So the displacement vector represents the distance and the direction of an object, right? So the object's displacement vector is drawn from the object's initial position to its final position. So let's say, Jane start here and then Jane ends here. Again, go back to the, last lecture. We see displacement. We only care initial and the final position only. But this case, this is in two-dimensional space, right? So you just connect the line starting from here, ending here. So this is your Jane's displacement. And the same start here, ends here. So then if you connect this line, this is Sam's displacement, right? So this is again regarding this over actual path, right? So that means if Jane start here and then doing this and ends here again, Jane vector, displacement vector is again the same, right? So the net displacement for a trip with the two legs is the sum of the two displacement then made it up, right? So in order to add two displacement or two vector, so this is about adding two vectors. So let's say first vector is moving to the east, and the second vector is moving to north. So it's like you start from your origin and then moving to the right one step and then moving to the up another step. And then how can you find your final position relative to your initial position? So again, this is your displacement vector, which is the sum of these two vectors, right? So you simply connect. So the easiest way to add more than two vectors, so you just draw the first vector and then draw second vector and draw third vector and draw fourth vector. Just connect, tail to head, tail to head, tail to head. And then this is your initial, this is your final. So you just connect initial and final point. So this is a vector sum of 1, 2, 3, 4 vectors. Okay. So then, if you want to add just two vectors, right? This is the first vector, this is the second vector. So draw vector A, like you draw here, and then place the tail of a vector B at the tip of A. So you move your vector B to A, and then draw an arrow from the tail of the, to the tip of the B, and then this is the vector A plus B, so you connect the very first position and the last position, right? It's very simple. And then before I ask more question, let me briefly, explain more of a vector. So I have one question. Let's assume you have a vector A. So that means, this vector. So this is a 1, 1. So that means this vector tells you move 1 meter to the east and then move another meter to the north. Or you can directly move to northeast root 2 meter with a 45 degrees, right? So my question here is, okay, you have this vector here, and then another vector is at different location, and it's located here, for example. So you have another vector here, magnitude the same, 45 degrees. Sorry. Oh, dang. Let me redraw it. Sorry about that. You have a coordinating system. You have a vector 1, 1, and somewhere here, and at some point here, again, your shape of the A vector are the same. So again, the length is 1, horizontal length, vertical length is 1, and then I'll call this is A vector, and I'll call this is a B vector. The thing is, the shape, the length of each, the vector A and B are the same. In other words, this length is root 2, and this length is root 2. The angle from the horizontal line is a 45 degrees. Here is a 45 degrees as well. And then let's assume you have another vector here, the same shape, right? We'll call this is a C vector. But again, length is root 2, angle 45, and I'll call this is a C vector. So the question, A vector, B vector, and the C vectors are the same or not? Pose and think. And then the answer is a yes. A vector and B vector, C vectors are the same. So the vector, whenever you describe a vector, you describe two quantities of each vector. The length. So vector A length root 2, vector B length root 2, vector C length root 2. And then angle from the horizontal. Vector A, 45 degrees from x-axis, horizontal line. Vector B, 45 degrees from horizontal line. Vector C, another 45. So as long as they have the same magnitude, length, and an angle from the horizontal, vector A, B, C are the same. Okay, so vector actually does not depend on its location. So you can place a vector here. You can also place a vector here. You can also place a vector here as well. C vector, I'm sorry. Okay. So then now you see this makes sense, right? So initially a vector was here, B vector is here. But now you draw your A vector here. But now see, let's assume this is your coordinating system. Your origin is here. Your A vector was initially here. But now you can move your A vector to any location as long as it has the same length and then angle from the horizontal line are the same because the A vector here are the same. So you're free to move it. And then same for the V vector, because even though your initial V vector was here, you can move your V vector at the right here, right? So feel free to move the vectors, but don't hurt its length and then the angle, right? So then the way you add the two vectors, draw the first vector and then draw the second vector, head, tail, and then connect your initial tail to the final head. That's how you add the two vectors. And then if you want to add more than two vectors, again, same. A vector, B vector, let's assume this is your C vector. And then let's say this is your D vector. So then A vector plus B vector plus C vector plus D vector is what? This is your initial, this is your final. So just connect it, and then this is your D vectors. The sum of A, B, C, D, right? So then, given vector P and Q, what is a P plus Q? Pause and think, choose the answer. P vector again, here. So in order to add them, you have to move your Q vectors at the head of P. So you just have a move P, Q here. So now you have a same Q vectors, right? So then this is your initial, this is your final. So basically then you can connect. This is a P plus Q. So the answer is a A. Another one, pause and think. Again, your P is here. I'm sorry, this is the answer. So now, sorry about that. So now you have an Anna work 90 meter due east and then 50 meter due north. What is her displacement from her starting point? So then, again, same question. You have a 90 meter and this is your origin, right? And then you move a 50 meter, right? So her displacement is what? Vector sum over A vector and B vector, which is this. So the question is simply finding her displacement. So the magnitude is what? Root 2, 50 square plus 90 square, right? So then you see magnitude is 50 square plus 90 square, which is 100 meter roughly. So then you see this is 100 meter, right? But that's not the answer. Why? Because you're looking for displacement. Again, whenever you are asked to find displacement or velocity, which is a vector, you have to always describe two quantities, right? The first one, magnitude, and the direction. So for this case, you have to find this angle theta as well, right? So again, whenever you describe vector, again, two parts. Magnitude, the actual length of the arrow, and the second part, angle. But angle, you in general say angle 30 degrees. That means your angle is from the horizontal. So in other words, okay, you have in a coordinating system, you have this vector, and then whatever length is doesn't matter. And let's say this is a 45, and then you say, let's say this is root 2, then you can say this vector is a root 2 comma 45 degrees. And then now let's assume you have another vector, but now this is this way, length the same, but this angle is a 45 degrees. So then what is this vector? Again, root 2, but the angle you always measure from the positive horizontal x-axis. So it's a 45 plus 90 degrees. So this is a 135 degrees. So again, in order to find this displacement, you need both magnitude, the angle. So then how you find the angle? Right? Here, you can use a tangent inverse function. Right? In other words, again, let's go over tangent or inverse function. In general, what is your tangent theta? Tangent theta is what? 50 over 90, right? So this is a 5 over 9. So then inverse function is what? What makes tangent value? What angle makes tangent value 50 over 9, 5 over 9? Right? So then this is a 29 degrees. So then this is a 29 degrees. So your final answer must include two parts, magnitude and the angle. But you don't need the north over east, right? You can simply say 29 degrees. So that means angle from the horizontal is 29 degrees. Okay. Today's lecture seems like a very straightforward, very simple. You feel like, okay, I think it's easy. I don't need to go over, but make sure you have to go over all example I showed you today, and then make sure you understand it because I have seen, this is one of the most, misunderstandings, I see every semester. Okay, so make sure you understand this lecture, and then I will see you guys on Tuesday.